Hello there and welcome to the Rocket Lasso Utility Spline Explainer videos. In these videos, I'm going to be going very methodically through every single setting inside of these 5 different tools so that you can mechanically know exactly what everything is doing. If you want, you should definitely check out the quick start video where that's a little bit more artist friendly and it's more project based, where we're not worried about the mechanics of what each setting does, but more of like, let's jump in and start using it. So anyway, we'll be stepping through each and every tool kind of methodically, talking about the shared settings, etc. To begin with though, we've got a nice spline here from vectorworldmap.com. You can head on over to the website and get a nice, really detailed version of the entire world map here, and that's what I'll be using for a bunch of this demo because it's just really fun to play with. To begin with, we need to track down the tools. After you've installed them, you should find them under your plugins, or more recently, extensions dropdown, where you'll find a flyout RKT Utility Splines, and inside here, 5 different utilities. We'll begin with the Smooth, selecting the world map. I'll drop that as a child, and you're not going to see too much of a difference, but let's zoom up to an area with lots of detail, and let's take a look at some of what's going on. The main thing that this particular tool is doing is a number of iterations to smooth it out, very similar to the Cinema 4D smoothing deformer. Let's decrease this down to 0, and you can see we get all this crazy detail traveling along the entire edge, and as we add additional iterations, they are getting smoothed out, and everything's getting kind of rounded and a little bit cleaner, a little bit more simple. So that's the main function of this. But let's step through a little bit about some of the various settings. To begin with, these are shared between all 5 of the tools, and that is which utility are we using. Right now it's under Smooth, which obviously is this tool, but here's all 5 different tools. We switch this over to Cleanup, and you'll see that the name will change, the icon will change, but that can get jumped back to any one of these at any given moment. It's just kind of a handy feature to jump around quickly. Next up is the sources. This is pretty much identical to our tool Ricochet and Slicer and Mesh the Spline, where right now it's set to children, so we can drop children directly under the utility, but we can switch this over to objects mode, and now I can, instead of having it be a child, I can drag the spline in and link it remotely. So as I add in smoothing iterations, you can see how we've got the original spline and the smoothed out spline both at the same time. This could be useful if you want to get access to a spline that exists somewhere else, or an easy example here would be I'll make a duplicate of the smooth, and let's do more iterations, and there you can see I've got the original and one that's modified and another one that's modified in a different way. Delete the second one. Back into Smooth. There's 2 additional settings here where we can hide the original object just via its stoplights or turn it back on again, and I could turn on and off a particular input spline if you had more than one fed in. So pretty straightforward. Now in Ricochet and Mesh the Spline, I often find myself using this objects dropdown, but when it comes to utility splines, I've been finding children is the one I reach for more often. So back to children, I can drop the spline as a child again, and again it's getting smoothed. Moving on, actually let's talk about kind of mechanically what's going on a little bit. So under iterations, you can see that we've got a point here and a point here and a point here. If I give it one iteration, what's happening is this point is looking at its neighbor, and it's looking at its other neighbor, and it's going to the average position between them. And every single point is doing that. And as you add iterations, it's a feedback loop where it takes the previous modification and feeds it in again. And it does that again and again and again until the entire thing is getting smoother and smoother and smoother. And you see how all of this detail has now, all of that crazy detail gets smoothed out to one kind of implied shape. And that's, of course, applied everywhere. Now, if you want to get technical, it's a little bit more complicated than that. We found that averaging out just the direct neighbor wasn't as fast or as useful as looking at the neighbor and the neighbor's neighbor. So it's actually averaging out those 5 points together. And then we're doing all sorts of algorithms to make sure that there aren't oscillations and feedbacks. But for the most part, you can just think of it as the points averaging to where their neighbors are. Now, I love to move on to counter scale, but this scene file doesn't show that off very well. So let me pop open this file instead. What I've got here is a pretty simple spline. You can think of this like a motion captured camera, like you were tracking your phone's position to get like realistic camera movement, but this ends up being a little bit too jittery. There's too much detail and you want to smooth it out a bit. So let's drag in a new smooth utility. So with the spline selected, a little trick you can do is hold down Alt as you create any object really, but in this case go down to Smooth. Because I'm holding Alt, the spline will automatically become a child. Now immediately you see that the spline has gotten smoothed a bit. I can drag this back and you see here's our beginning spline, and I can add in iteration after iteration until it gets smoother and smoother, and let's go pretty far here, and now it's become very smooth. You see these nice clean arcs traveling through the whole thing. But a problem you can see is, as I drag this back, it's definitely shrinking. As you average points together, they're going to tend to get closer together. So what if we don't want this to shrink? Well, that's what counter scale does. If I start increasing counter scale, you're going to see the entire thing looks like it gets larger. Dragging the iterations down to nothing, you see that as these average out, their average size is being maintained. So you can see that that did not shrink down too much. Let's make an entire duplicate here. Actually, let's make a copy of the original spline. And you can see here's the original spline, and here it is counter scaled. And you see how we're maintaining that distance very well. Where see this one kind of pushed out to the left, this one pushed out to the right, but now we're getting that nice clean average in between the two. So that is counter scale. There's actually a couple of additional settings that are interesting inside of counter scale. This might not be visually the best way to show it, but we left it unclamped. So yes, you can go up to 100, but you can actually start pushing it even beyond that. So I could say actually counter scale even more. And if you want to be technical, what's happening is we've got the original spline here, and the point's gotten modified and smoothed out to a particular position. So we're saying, well, what distance did it travel? Okay, start counter traveling back to its original one. But because we want it to be smooth, we average it out next to its neighbors. And so you end up with this kind of averaged out distance, which allows it to be pushed out. We can counter scale beyond 100%, as you see here. And you can also, in an interesting way, go negative onto counter scale, which means it's going to push it even smaller. And eventually it's going to kind of explode and do all these crazy things. Is that super useful? I don't know, but I've always liked settings being unclamped because you never know what you might end up with. So this is kind of fun for who knows what. So that's some counter scale. Important to note also with our iterations that goes up to 50 with the slider, but that is not clamped either. I can keep on pushing that as far as I want. And if we give this enough iterations, eventually we'd end up with pretty much a perfectly straight line. You see this is like 19,000 iterations, but that is converted this big spline into this nice simple arc. Moving on, we've got stiffness. I'd like to show this in a different file again. So let's drag this text in. So we've got the GG font, which I'm pretty sure none of us have actually ever really used, but it's a good candidate for feeding into a smooth utility. So let's drag a utility smooth, feed that directly in. You can see immediately it's gotten smoothed. Let's add in some more iterations until we end up with something very smooth looking. It shrank, so let's counter scale that up to be a bit larger. And turning that on or off, you can see that we have modified it, but it's maintaining its original shape pretty well and nice and smooth. Now actually looks like the type of font that might be at a smoothie shop. But anyway, let's talk about stiffness. Stiffness is going to morph our modified shape. Keep in mind, exact same number of points, but it's going to transition this back to the original state so we can morph in between those two. Now, it's a visually similar but distinct effect from changing the number of iterations. If we go back to the iterations, as I add iteration after iteration, it's kind of doing this morph from one to the other. You see that there's a little more complexity in the way that those are transitioning. Look how this shape, especially the right side of the T, is kind of pulling in. But if I give it a bunch of iterations and we instead grab stiffness, it's a direct transition from one shape to the other. You see, even if I go back a couple percentage, you start getting the bumps back in again, which is not the case if you're doing the iterations. Increasing stiffness all the way, you'll see that there's a little twirl down next to stiffness. If I twirl that down, we have a checkbox that says use fields. And anywhere we can put fields always makes tools so much more powerful. So in this case, I can say, yes, use the fields. It makes a new stiffness field tab. And here we have a Cinema 4D field input. In this case, let's make a linear field. And now you can see that with this linear field, I can transition from a stiff state to the iterated state just by slowly passing this through. So there's lots of potential for that to create some nice, crazy advanced animations. And I want to just throw out there that that is an option for you. Let's see, the next setting is actually first and last point. That'll be best shown in the camera path file. So moving back into this file, let's add in some iterations again. So you see it's nice and smooth. What I'd like you to pay attention to is we got the first point of the path and the last point of the path. And currently first last is set to lock. So as I increase this, the first point and last point aren't moving. They're staying exactly where they were originally. But we have alternative options like smooth. Smooth means that point isn't stuck to where it originally was, and it's going to get averaged out just like the rest of them. So you see that these will actually start pulling in a little bit as it gets averaged. So, there's definitely times when that is something that you're going to want it to be able to do. Next up is loop. I'm actually not even sure if this is going to be useful to anybody, but it's going to make it so that the first point and last point are acting as if they're closed and they start looking at each other. So as we add in iterations, they get pulled almost like magnetically towards each other until they're looping around. We've got lock, we've got smooth. Next up is minimum length. Minimum length is definitely going to be best shown here on our big map. Let's begin by setting minimum length to 0. You'll see immediately that there's actually a whole bunch of little islands that had disappeared and a whole bunch of lakes. Now, what exactly is going on here? Well, if you were to take the perimeter of it, if you take the distance from point to point to point to point, we're adding all those together and we're seeing if it is above the minimum length. If it ends up being below the minimum length, we get rid of it. So let's just start increasing this minimum length. And as I do, we're going to start seeing these smaller islands begin to disappear. And we keep on pushing it further and further and further. If we were to, let's reset that to be small, go zooming out. And you'll see that here we got all these tiny little islands and lakes, which could be distracting depending on what you're doing here. But as we start increasing the minimum length, those will begin disappearing until we're just left with the large land masses and very large lakes and seas. But you keep on pushing this further and further until entire countries start disappearing, and then there goes New Zealand, and then Australia, and eventually we're just left with the final giant spline there. So you can get rid of them. That's actually pretty useful. I can think of a bunch of uses I might have for something like that. The mechanical reason why we added that in, let me show you. I'm going to get rid of all of the minimum length set to 0, so they're always there all the time. And let's begin adding in some iterations. And you'll see that as I add in iterations, because they're getting averaged out, they start shrinking. As they get averaged, they get pulled towards each other and they shrink. And eventually they get really, really tiny. And we can even push it further and further to the point where they're almost going to visually disappear. We can see like a pixel, just barely see it. Maybe you can't even see it with the compression, but they get really, really tiny. You can imagine that if those are getting extruded, if those are being swept, if those are being rendered in Redshift, that could create problems. So that's why we made minimum length. So if I turn that on, as the different islands shrink below that threshold, they will disappear and not get returned. So it's kind of useful in two different ways. You can use it just to crop things out that are really small, and you can also use it to stop tiny little microscopic circles from continuing to exist when you don't want them to. Next up, we actually have our point input, but I'm going to save that for when we're talking about the resample tool. So moving on, let's talk about the tick marks. Let's hide or turn off all those iterations, zoom way up. And currently we are seeing none when it comes to tick marks, but we can say, let's say I want to see exactly where the points are falling. I can click on show me the result of our current tool. And you can now see that we get these tick marks everywhere that there's a point. Now, overall, this is a very tiny spline with a lot of detail. So these are all very clustered. So we can change the scale to something smaller like 0.1. With these tiny little tick marks, we can now see exactly where the points are falling. And as I add additional iterations, we can see how our points have moved to new locations. It just gives you really good feedback. We also have the option of clicking to see where the original ones were placed. So you can see how it is modified from one to the other. And we go back to none. Something important to note, let's go back to result, is you'll only be able to see these tick marks if you're in model or object mode. If we go to something like point mode, it just doesn't show this type of interface. So you have to be in model mode to see it. Unless you turn on our checkbox called always display, and now it doesn't matter what mode you go to, they will always be turned on even if you deselect the object. So if we needed feedback of that, it is now showing everywhere. Something worth noting though is if we say don't always display, and I'll go to none, something that's handy is maybe you want to see what your point count looks like here. Well, you can do it very quickly by not going into the object. In fact, let's say we're in this spline here. It's like, I want to see what the point count actually kind of visually looks like. If you double click on a utilities icon, then it's going to automatically activate the result. And if I zoom up here, you can see that we are now showing the tick marks. If I double click again, it'll turn it off. So pretty much it's just alternating from none to results, but it ends up being really useful to be able to turn that on and off very quickly. Also, If you're in some other mode, like let's say point mode, if you double click, it'll actually set it to model mode so you can actually see them turned on. So just another little useful thing for feedback. I definitely find myself using that depending on the circumstance. Very handy. So those are all of the basic settings here for the utility spline. We've also got this question mark button, which will pretty much bring you to a page that'll show things like this video that you're watching right now. And with any luck in the future, although I've had bad luck, there should be an examples page of scene files that you can check out. But of course, the utility splines do come with an entire folder of example files, so make sure you go and check that out. Now, let's move into the Advanced tab and talk about settings that are specific to the smoothing tool. First of all, we've got a point cap, which is pretty important because overall, this spline, you'll see if I select the original spline and go to point mode, this is actually made of 55,000 different points. So that's a lot of different points. If you fed something in that was like way too many points, you don't want it to be taking forever to calculate. So we put a point cap in there to stop it from breaking. To show you what it does, let's begin decreasing this, and I'll drop this down to, let's say, 10,000, which isn't enough to show everything. So it's going to draw as many of the points as was possible, and you'll see as I decrease this, it's actually going to be erasing out the points as it goes, which could be a cool effect. I haven't really thought about doing anything with that, but it's kind of like unweaving it as it goes. Now, a couple of things to throw out there. If you are exceeding the point cap, let's go to the main tab, you'll actually see it says exceeded point cap. And there's an override button for you. In addition to that, you'll see the icon has grayed out and they made a little X. And that's just to give you a heads up that like, hey, it might not be functioning the way you think it is. So you can click the override button. And what that will do is look at exactly what the point count is and set it to the exact point count. So that means that it's not going to create any more points than it needs to. But at that point, at least you've decided that definitely you want to go for this large number. Shrink that back down again. Something else that's neat to show is we've got that icon showing the X. If you're ever seeing the icon with the X, that also means you can just double click on the icon and it will trigger the override as well. So again, just trying to make things handy and fast for the user. So that's point cap. Next up, we have the use neighbors checkbox. I had kind of mentioned that earlier when we were talking about the way the algorithm works, where if we're really zoomed up, and we're averaging out, that's going to be averaging from this point to the next one, and from this point to that one, they get averaged. But it's almost twice as fast to calculate if you say actually average this point to its neighbor and its neighbor's neighbor at the same time, and that helps stop oscillations from happening and things like that. But maybe there's a reason you don't want that to happen, so you can actually turn that off, and now it's only looking at the direct neighbor. There's chances if you didn't want to smooth too much that might maintain a little bit extra detail where it can actually follow the shape a little bit more. But in general, we have found that neighbors is very useful. Next up is remove if 2 or 3 points. This one's very specific but pretty important. It's more for resampling things. In fact, I think we won't see any examples of this until we resample something. But pretty much all this means is if for some reason there is a floating segment and it gets down to only being 2 points, it'll disappear. And if there's a closed shape and it gets down to 3 points, it will disappear. This would make them reappear, but you'll see that more when we talk about resample. So we'll wait till then. Next up are some very specific settings. Because I said this is the technical video and we're talking through it, I will explain it, but they are very specific. Moving back into this camera path file, we were talking about how we can counter scale as we increase iterations. We can say, okay, we want to keep that scale. Well, as I had been explaining, we've got the original position and we've got this modified position. So counter scaling essentially means, okay, I traveled, let's say 10 units to get to this average spot. Push out in that direction about that amount. And the way we say, well, about that amount is us averaging things out. And we're averaging out by doing distance iterations. Essentially, we're looking at a point and then we're saying, well, how far did you move? It's like, well, I moved 10. It's like, yeah, but how far did your neighbor move? It's like, well, that one moved 11. How much did your neighbors move? And it's like, well, that one moved 15. So it's going to start averaging those numbers out. And that's how we can get this averaged out curve. And in the same way, we've got these tangent iterations, and that's what direction it should travel. Let's say that this point was morphing from where it originally was to the beginning. Well, it's going to travel back in a very sharp way to where it used to be. But we're now saying, well, what direction did your neighbor come from? What direction did the neighbors come from? And each of those iterations smooths it out further. Now, technically, you can get some interesting looking effects by changing the number of iterations. I'd say for 99% of people, 99% of the time, these defaults of 10 and 20 will be fine. But I could say, hey, don't average the distances, and you're going to see that this is actually going to start almost taking the original shape and just pushing it out further, almost growing it in a way. So as we counterscale further, it's going to take kind of that original shape and exaggerate it out further. Averaging that back out, we've also got the tangent iteration, so it's the direction that they're going to be heading. So we can decrease that, and you're going to see that these shapes end up getting very warped. You can also smooth out further, but now they're not going to be traveling in that direction. Like I said, I think we got some good average amounts here, but these are there for you to manipulate if you want to. Next up is actually just a handy little thing, which is giving you feedback on your point count. So let's go back into the smoothing demo with the whole world map, because here you can see that we are getting a shape that is like 50, almost 57,000 points. And in this case, we are doing a lot. Let's open up both tabs. We are, as I say, increase this minimum length, it's actually removing different sections. So under advanced, you'll see that we've gone from 56,000 down to 37,000, meaning we're only using about 65% of the original points. This will become a lot more important when we get into the different point modes and the resampling, where we'll be increasing and decreasing points constantly. But that is some point feedback for you, just giving you more information overall. Now, there will be a standalone video explaining the spline tab, because this is identical in all of the tools and deserves its own little video. It'll be a short one, but I believe that this will wrap up this very first video. Jump in for the next one, where we will be talking about the resample tool. Thanks.